All right, we made it to the last section in chapter 3, which is section 10, derivatives of inverse trig functions. Your book does a really nice job in theorem 3.20 that gives you just the overall idea of what these derivatives are for the inverse trig functions. But they only give you the very special case where the argument of the trig functions is nothing more than just x, okay? So what I'm going to do is I'm going to pick on, we'll pick on a tangent here. So let me circle it. And I'm going to give you the general rule, and this applies for all of them, okay? So d dx of tangent inverse of u, and we're going to say u is a function of x. All right, so the derivative of the inverse tangent of u is going to equal 1 over 1 plus u squared times du dx, because you got to apply that chain rule. So make sure that you remember that from all the examples we did, which is basic trig functions. So this is just basically the same thing. It's just, what's really nice, you got formulas. All you got to do is just find a correct formula, substitute appropriately, simplify appropriately, and that's it. So here's an example right here. We'll go back to one of my favorite examples, just finding the equation of a tangent line. So find an equation for the line. Tangent 2, y equals 1/4 inverse tangent of 1/2 x at the point 2 comma pi over 16. Okay? So the first thing, remember, when you see the words, find the equation of the tangent line, or find the equation for the tangent line, you need a slope evaluated at some point. We'll call it xy. All right, you need a point itself, which we already have above. And 3, y minus y1 equals your derivative evaluated at some point times x minus x1. So the first thing we're going to do, let's find a slope. The slope is going to be our derivative. Now, earlier, I gave us this formula here, d dx of the inverse tangent of u is going to equal 1 over 1 plus u squared times du dx. So for us, dy dx is going to equal 1/4 times 1 over 1 plus x over 2 squared times 1/2. Now, if you're wondering where all this came from, let me zoom out here a little bit and let me show you. We have the function y equals 1/4 tangent inverse of 1/2 x. Now, I'm going to just underneath the derivative, I'm going to pull the 1/4 out front. And then what I need to do is take the derivative of the inverse tangent of 1/2 x. So that's going to equal my 1/4, which I pulled out front of the derivative, times 1 over, now I'm just following my rule, that's it, 1 over 1 plus x over 2, because it's 1/2 x, or x over 2 squared, times the derivative of 1/2 x is just 1/2. So that's how I got 1/4 times the quantity 1 plus, or 1 over 1 plus x over 2 squared times 1/2. And what I can do is, if I wanted to, and I'm going to do it, I'm going to clean this up a little bit. So dy dx is going to equal 1/8 times 1 over 1 plus x squared over 4. And then I'm going to factor out a 4 to give me 1 over 2 times 4 plus x squared. So if you need to, just go ahead and do the algebra on that. But well, all I did is just factored it out. So there's my derivative. Now I'm going to evaluate that. Just rewrite it here real quick. Evaluate this at x equaled, what was my point again? 2 comma pi over 16. So I'm going to evaluate this at x equals 2. So when I evaluate this at x equals 2, I get dy dx equals 1 over 2 times 4 plus the quantity 2 squared, which is 1 over 2 times, well, 2 squared is 4, 4 plus 4 is 8. So this is 1/16. So I know what my slope is of my tangent line, 1 over 16. Now, I got my slope, I got a point. My point is 2 comma pi over 16. Step 3, y minus pi over 16 equals 1/16 times x minus 2. And then I'm going to just go ahead and distribute. Y minus pi over 16 equals 1/16 minus 2 over 16 is 1/8. And lastly, I'm just going to add pi over 16 to both sides to give me y equals, oh, I forgot my x up there. 1/16 x minus 1/8 plus pi over 16. If you really wanted to, you can find a common denominator between the 8 and the 16 and just make that one big numerator. But you don't have to if you don't want to. And that's it. So the key to doing inverse trig functions is just following the formula. That's it. So I hope that helps. That's going to be it for chapter 3. It's all about derivatives. Chapter 4, we're going to take everything that we learned about derivatives and we're going to apply that to related rate type problems. We're going to be looking at maximum and minimization problems. We're going to be looking at points of inflection, concavity, intervals of increasing or decreasing. So we look at the applications of derivatives and what derivatives can tell us about different functions of x. So I hope that helps, and I'll see you in the next chapter. Later.